Okay, let's prove the one of the theorem that derivative of sine x is cosine x. Okay, so by definition, this is the proof. Derivative of sine x is limit h approaches to 0 and this is sine x plus h minus sine x, right? So now you're going to use the formula for the sum of the angle for the sine. Limit h approaches to 0. And then this is sine x cosine h plus sine h cosine x minus sine x. Okay, so now that is the limit h approaches to 0. And I'm going to combine this term and that term, factoring out sine of x. And I have cosine of h minus 1. And then this term I'm going to just rearrange. First, write cosine of x and sine of h. Okay, I mean, nothing has changed. So this is now, because this x and x is now independent of h, I can take sine x out and then put the limit after that. H approaches to 0. H of cosine of h minus 1 and plus I take cosine x out and then limit h approaches to 0. That is h sine h of h. Okay, so I'm going to evaluate now this limit and this limit separately. If I call this a and b, I'm going to evaluate a first. So consider limit h approaches to 0, sine h over h. Okay, so now let's draw let's say part of circle and radius 1. So I'm going to call this 1, 0 and 0, 1. And then there's some kind of sector. So I'm going to draw a tangent line there. Oops, I can draw a little better than that. So small, okay, so barely touching the tangent. So now, so this is tangent line like this. Okay, so this 90 degree and this 90 degree. Okay, well, they're touching it. So here, 90 degree. So this is 0, and let me use the same notation as the textbook so that when you refer back to the book, you're looking at the same diagram. So this is called C, and this point is A, and there's 90 degree there, C, and then this 90 degree also, and this is B, and then this intersection is E, and this is I'm going to call D. Okay. So now, if you look at it here, so if I call this theta, because radius is 1, BC, the length BC, is definitely less than the arc AB. Okay, let me write instead of BA, let me write AB. Okay, so AB is less than AE plus EB. Then AE plus EB is less than, that's not difficult to see, AE plus ED. Okay? But then AE plus ED is actually AD. Okay. Now, what is a BC? The BC is simply sine of theta. Sine of, I'm going to use h because we're using, there's no reason why I changed to theta. Just keep the h, okay? Right? So now, so this is sine of h, okay? And then AB is, our theta is 1 times theta. And then AE is actually AD is a tangent of theta. Okay, so this is tangent of theta. Okay, so now we have this one case, and that's another case here. I'm going to evaluate those. So if I call this 1 and this is called 2, 1 is saying sine h is less than, why I'm changing to, sorry, that should be h, 1 times h and tangent of h, and that is also tangent of h. That should be tangent of h. Okay, so now, so sine h is less than h. So from here, if I divide by h, sine h over h, because they are all positive, less than 1. Now from number 2, h is less than tangent of h, meaning this means h is less than sine h over cosine h. This means we can always switch these two here. If a is less than p over c, then c is always less than p over a. So cosine of h is less than sine h over h. So we have sine h of h is less than 1, but sine h of h is greater than cosine of h. So we put them together. Sine h over h is less than 1, but bigger than cosine of h. This is always true. But what happened? Limit h approaches to 0. Cosine h, we know that is equal to 1. And limit h approaches to 0. This is for all h within, well, I'm going to say for all h go to all h, I say approaches to 0. Okay. So now, so this is limits, but 1 is just 1. So by squeeze theorem, limit h approaches to 0, sine h over h equal to 1. Okay. So like the this one, a is 1. Now how about b? B is, now consider b. What is the b? Limit h approaches to 0. Now b is what is the b? Cosine h minus 1 over h. Cosine h subtract 1 over h. Okay. So this is same as I multiply both sides by cosine h plus 1. Cosine h plus 1. So this is limit h approaches to 0. Cosine square h minus 1 over h cosine h plus 1. So this is limit h approaches to 0. So this is negative sine square h. Where they come from? We have sine square h plus cosine square h equal to 1. So cosine square h minus 1 is negative sine square h. Okay. So now this is sine square h over h cosine h plus 1. So this is same as I take the negative out, put the limit back. So limit h approaches to 0. This is sine h over h. And then you can already separate the limit. And then this sine h over cosine of h plus 1. But we already proved this part is equal to 1. Okay. So now, what about this part? So this is, negative 1, and then limit h approaches 0, sine h over cosine h plus 1. But simply, this is negative of 2 because cosine 0 go to 1. So this is 0, so this becomes a 0. So this portion b becomes 0. So we have derivative of sine x is, as you can see up above, right there, sine x times 0 plus the second portion is, what is it? Cosine x times 1, which is cosine of